I think the most common misconception in this particular space of AI is the fears around data being harvested. So AI is a large term now. It seems to encompass almost everything. But in the building space, when we talk about AI, we talk about sensors and data and time series information. This is about actual sensor data, so temperature, humidity, occupancy, energy management, all of these pieces of information coming in, being automated into not necessarily actionable insights, but actual action itself. So a sensor tells you something about a room, and then some end effector changes something about the space to enable efficiency of that space. So it could be, you're wasting energy here, so we're going to turn it off there.
The most common misconceptions I get about AI in building control is that, one, that they might be using too much energy themselves to reduce energy, which does seem counterintuitive. I think it's important to realize that not all AI is equal, and actually AI is a subset of lots of different technologies. Some of them do use a lot of energy, some of them don't. For example, measurable energy, we don't use much energy at all. And actually any energy we have is all bundled into our customers' return on investment.
It's about using the data that we have, which already exists. It's just falling to the floor right now, being able to gather that up, organize it, drive meaning from it, understand how it's interrelated. I think that's probably the biggest gap.
I really think AI can be the analyst that supercharges us. I think there's lots of opportunity to find efficiencies in whether that's energy consumption, whether that's tenant engagement, and hopefully, I hope that it means I can spend less time reporting and looking at the data and finding data gaps, etc., and instead driving action on the ground.
The exciting piece about the built environment is not that it's AI, but not AI in the sense that we think about chat GPTs and language models and bots, but we think about forecasting data and managing larger volumes of data in a way that's really useful for people. And historically, the challenge I think we've had is that we just throw sensors into a building, they produce a lot of data, we throw that data at a very tired facilities manager or someone who's responsible, and they're like, I can't possibly process or manage all this information, and then they get a bit tired of the sensor, the technology, they lose trust and faith in it. So where AI, I think, is doing its job really well, it's to stand in the way and make sure that data comes in a usable fashion, in a semantic fashion ideally. So rather than saying the temperature across the buildings is an average of X, it says, the temperature is okay, everything is okay, or there is a problem and the problem is here, yeah? Or better yet, there is a problem, the problem is here and it's been solved. Simple as that. So that's where I think the advantage is. So deploying sensors, yes, to get really useful data, but not just vomiting this raw data directly at someone. It's about making it tangible, making it meaningful, and presenting that information to decision makers. But at sort of measurable energy, we like to think that we are the cheapest per kilowatt hour saving you can make, because the cheapest kilowatt you can have is one that you don't use. So yes, you could buy a more efficient television, or we could just turn it off when it's not being used and immediately save that energy. So this is functionally, it needs to be a scalable approach. So you have thousands of sockets in your building. It would be impossible to manage all of those manually. You'd be running around all the time. It would be impossible. So what we do is we automate that process. And that's where we think AI has its biggest value, in taking a great many things, simplifying that information, and then automating the action to reduce the cost of energy and bring a return on investment under 2 years.